Hey, everybody. Um, Welcome back after the weekend. Hopefully, it was a good one for all of you. I still haven't figured out what the number of the day is, but I thought a little bit more about it. I need to find out if if we've got any planned days off or how that last week or two of school is going to work before I can commit to something. But I think it's actually going to be surprisingly low once we find out what it is. But in the meantime, we're going to be moving on today, solving trig equations. And um, Well, when we see trig equations, they're going to be equations with trigonometric ratios in them, like um, 1 plus sine of theta equals 2 or something like that, and we'll have to solve it. Now, the ones we're going to be doing today are going to be relatively simple, but I first wanted to talk about the different types of questions, not the equations we're solving, but the way a question may be asked. They may say solve, finding all the real values. They may say find some of the values on a restricted interval. That's actually the ones that we'll be doing the most of. Or every once in a while, you'll see something that asks for the principal values. So if I say, I'll start with the second one because it's the easiest one to think about. If I say find the solutions on the interval between 0 and 360 degrees, then I'm looking for an answer that is something like, I don't know, I don't have any equations, so I'm not really solving anything, but maybe I've got 60 degrees and 300 degrees. And we'll see. Most of our questions will be something like this, where we'll get two different answers, and that's it. If I say solve, find all real values of x, this is where things can get really tricky because there may be an infinite number of answers. If I say something like sine of x equals 1, well, on the unit circle, sine of x is equal to 1 whenever I've got an angle that's up here. And so that might just be 90 degrees, or maybe it's 90 plus 360, 450. Maybe I add another 360. I can go around the circle as many times as I want. Or maybe I go backwards. Maybe this is negative 270, or subtract 360 from that. Let's see, negative 270 minus 360 would be negative 630. I'm not positive on that one, but basically you could have an infinite number of solutions. Now for something like I'm doing here, if I'm actually solving this equation, sine of x equals 1, well, then my solution might look like, well, I can't list them all. There's an infinite number of them. So maybe I give one of them. I'll say it's 90 degrees. That's the first one that I would think about. And then as my way of saying that I can just keep adding 360 degrees or subtracting 360 degrees, I'm going to say plus 360 n times, where I'm just going to go to my text function here, where n is an integer. Oop. And this is my way of representing this, my way of saying there's an infinite number of solutions. One of them is 90 degrees, and then I could add 360 any integer number of times. And an integer is a whole number, but it could be positive or negative. So maybe I add 360 once or twice or 10 times or 52 times or negative 5 times. Because n is allowed to be negative also. We're not going to deal a whole lot with this one, but I just wanted to make you guys aware that if it asks you for all real values, you end up with this type of an expression. And then finally, the principal values, basically those are the answers that your calculator gives you. And we'll be doing more of this on a different day also. But if I have an equation like sine or cosine, cosine of x is equal to something, the principal value is the one value that is between 0 degrees and 180 degrees, or between 0 and pi if we're doing radians. For sine or tangent, the principal value means the one value that's between negative 90 and positive 90, or negative pi over 2 to pi over 2. The reason that we've got two different ranges for these things is because if you have a cosine of x is equal to 1/2. There is only one value between 0 and 180 degrees. There is only one. Whereas if I said sine of x is equal to 1/2, and we'll see problems like this in just a minute. Actually, I've got one right here. If sine of x is equal to 1/2, we will find two different values between 0 and 180 degrees, but we'll only find one value between negative pi over 2 and pi over 2, and the same would be true for tangent. We're going to be looking at these graphs, sine, cosine, and tangent, a lot more moving forward in the next few days. I think we're going to get to that in the next, I guess, the next chapter. So that might not be until later next week. But anyway, that's what it's asking for if it asks for a principal value. Similar to finding all the real values, we're not going to do a whole lot of this. But in the case of solving something for the principal value, why can't I extend my screen? It's probably hiding under this. There we go. In a case like this, we would just get one answer, maybe, I don't know, 45 degrees. And that's it. You will only get one value if you're asked for a principal value. And this is also the answer that you're going to get from your calculator, which I'm going to say more on that in a little bit later also. Anyway, let's take a look at some problems that you'll actually be doing in your homework as you go to the assignment that's due tomorrow. And this is how I'm going to think about it. We're going back to degrees on this one. I debated and I actually posed the question to the other functions and trig teachers if we wanted to stick with radians since we just learned that. And my understanding is that we're going to be switching back over to degrees for this, mostly because you guys are a lot more comfortable thinking about degrees than you are with radians. So this should go a little more smoothly if we're thinking about it like that. But the way I'm going to do these problems is similar to how we did problems where I say sine of an angle is what. Now, sine of what angle is this value? I'm going to be thinking about those same triangles that we've been thinking about. If the sine value is 1/2, we recognize that number. Hopefully, we recognize that number. That's the short side of the 30, 60, 90 triangle. This is a positive 1/2, which means it must be up. Sine is the vertical, so we're going up by 1/2. We could have the short, wide triangle over here in the first quadrant, or maybe we've got the short, wide triangle over here in the second quadrant. These are the two places on the unit circle where the vertical component is the short side of that 30, 60, 90 triangle. So if I want the solutions between 0 and 360, we've got one here at 30 degrees, and then one more at 30 degrees less than 180, 150 degrees. And so those are my answers. I am solving this equation. I am getting two different solutions. Just like if I say x squared equals 25, you got two solutions. It's +5 or -5. This equation has two different solutions. When I say find all of them, that's a hint that there's probably more than one. Not always, but probably. If I say cosine equals 1/2, same idea. I'll draw my lumpy circle over there. And now I'm thinking, where is the horizontal going to be the short side of a 30, 60, 90 triangle? So now I'm looking at the short side being horizontal. It's positive, so I'm moving to the right. I must have the tall, skinny 30, 60, 90 triangle, either in the first quadrant or the fourth quadrant. These are the two places where the horizontal component is the short side of the 30, 60, 90 triangle. So now here I've got 60 degrees for that one. I'm tempted to go with -60 degrees, but this said I wanted angles between 0 and 360. So we'll just have to go all the way around. Let's see, looks like we're either 30 degrees past 270 or 60 degrees less than 360. Either way, let's go with 300 for that one. Moving right along, I'm not sure if I want to do all these examples, but I do want to do a couple different types of ratios so we can think about how we do these problems. Tangent is equal to the square root of 3. All right, well, this is a positive square root of 3. Don't worry, we'll get to negatives in a moment. But this ratio is positive, which means we must be in the first quadrant where sine and cosine are both positive, or in the third quadrant, where sine and cosine are both negative. Negative divided by negative gives us a positive. And so now I recognize this number. Hopefully you recognize this number. We've seen this before. We know that it's not one of the 45, 45, 90 triangles, because then this ratio would be 1 or negative 1. And so we know that it's either the tall, skinny 30, 60, 90 triangle or the short, wide 30, 60, 90 triangle. So the question is, does that square root of 3 come from the square root of 3 over 2 divided by 1/2? Or does it come from 1/2 divided by the square root of 3 over 2? Which of these possibilities would give us the square root of 3? And you've gone in the other direction enough. Hopefully you recognize this type of an operation. This one, if I divide and then rationalize the denominator, I get the square root of 3 over 3. This one, if I divide and cancel out my 2's, I do end up with the square root of 3. So this is the one. This tells me that tangent sine over cosine. Sine must be the long side. The vertical side is the long side. The horizontal cosine is the short side, because tangent is sine divided by cosine. So that means we must be looking at the tall, skinny one, because the sine value is square root of 3 over 2, and cosine is 1/2, or possibly both negative if I'm in the third quadrant. So angles between 0 and 360, I've got 60 degrees here, and then all the way around 60 degrees past 180 brings us to 240. So those are my two answers, 60 degrees or 240. And there we go. Let's see, I might start picking and choosing which ones we do. Well, this is probably a good one for us to do. There's a reason I made this slide in the first place. If cotangent is -1, here's our first chance to talk about a negative. Well, if cotangent is negative, then tangent is negative. That means we must be in the second or fourth quadrant, because either sine is positive and cosine is negative, or sine is negative and cosine is positive. So we're looking at these two quadrants, second and fourth. If the cotangent value is -1, then the tangent value is -1, which means sine and cosine have the same size. One's positive, one's negative, but they must be the same size, which means we're looking at the 45, 45, 90 triangle in the second quadrant and in the fourth quadrant. So 45 degrees less than 180 is 135. And then 45 degrees less than 360 is 315. And there we go. I think I will skip this next one. I'll just maybe mention that if cosecant is equal to this number that you recognize, cosecant is equal to that would be the same thing as me saying sine of theta is the reciprocal of that. And either you know this off the top of your head, or you've done enough of these problems to recognize where this number comes from, but that is the reciprocal of the square root of 3 over 2. And if you need to write that out and rationalize and do all the cancellation, but there we go. So I'd be looking at vertical component as the tall side of the 30, 60, 90 triangle. Let's see, the answer would be 240 or 300 degrees. Sine is equal to 1. I kind of have talked about that already. Oh, this is a good one for us to look at. Tangent is equal to 0. Actually, I shouldn't just skip over that. This is one of those where the only answer is 90 degrees. 90 degrees is the only place between 0 and 360 where the sine value is equal to 1. So we actually do only get one value for that one. Sorry about this. I'm skipping around because I notice my video is getting to be a little bit long already. If tangent is equal to 0, well, that means sine divided by cosine is 0. That means sine, the numerator must be 0. The denominator can be anything. But if the sine value is 0, then tangent will be 0. And if the sine value is 0, that means we are right on the x-axis. We're looking at a 0-degree angle. 0 divided by 1 for tangent. 180-degree angle. 0 divided by -1 for tangent. And in this case, we get 3 values because 360 works also. Tangent of 360 would be 0 divided by 1. So 0, 180, or 360. And there we go. I think I'll skip this one. Also, I want to get to a couple different types of problems. Here we go. Here's a different type of problem. Notice the directions have changed. It says find 6 solutions to this equation, 2 of which are negative. So we start the same way as we've been doing these problems. If cosine is equal to 0, let's see, cosine, that means there's no horizontal component, there's no left or right. So we're looking either at an angle that leaves us up here at the top or an angle that's down here on the bottom. So I'm looking for 6 of them. I think I just found 2 of them at 90 degrees or 270 degrees. Those would be the 2 answers between 0 and 360 degrees. Or I could go backwards by 360 degrees or forwards by 360 degrees, clockwise or counterclockwise from either one of these. So I could also take that 90 degrees, rotate clockwise by 360 degrees to bring us all the way back to negative 270. Oops, negative 270. Or maybe I get to this point by rotating by a negative 90. There's my 2 negative values. By the way, this works like this for a cosine function that you end up with opposite values. That will not always work, but it does work for this one. And then I could take any one of these. I could subtract 360 from these. Those will give me more negative values, or I could add 360 to these. One more rotation past 90 degrees brings me to 450, or 270 plus 360. I believe that brings us all the way up to, must be 630 degrees. And these are 6 of the infinitely many solutions to this equation. I could keep adding 360 as many times as I want and get more and more and more solutions. If tangent is negative root 3 over 3, same idea as before. I know that this type of a number comes from either the square root of 3 over 2 divided by 1/2 or 1/2 divided by the square root of 3 over 2. Maybe you've done enough of these problems that you know off the top of your head. Maybe you need to try one out and see if it works. But this type of a number is going to come from 1/2 over the square root of 3 over 2. And maybe you remember a diagram that I showed you guys a few days ago, maybe it was earlier this week, where if you've got a tangent value that's this big, this comes from those angles that are close to the x-axis, the 30, 150, 210, or 330 degrees. Because I've got a negative value for my tangent, that means I must be in either the second quadrant or the fourth quadrant. So again, 6 solutions. Looks like I've got 150, let's see, all the way around here, 30 degrees less than 360 is 330. Or I could subtract and go with negative 30 degrees. Notice that 30 degrees wasn't a solution, but negative 30 is. Or negative 180 minus another 30 degrees, so negative 210. And now to find more solutions, add 360 to each one of these, subtract 360 from each one of those. I'm just going to go ahead and add 150 plus 360, and then 330 plus 360 to get my other 2 values, and I get 510 and 690. These are 6 of the infinitely many solutions to a problem like this one. And then finally, the last type of question you'll see in your homework assignment due tomorrow. If sine is equal to this value, then find all solutions between 0 and 360 degrees. The directions on your homework will say, hint, you will need to use your calculator to find one of them. And so we got to talk about how to do this on our calculator. If sine of theta is negative 0.123, then the algebra that I'm going to do, we'll talk more about this in upcoming days, but I am going to undo the sine function with something called the inverse sine function, which you have seen before. The answer will be the inverse sine of negative 0.123. And technically, we've been doing this for the last half hour. We've been doing inverse sine, inverse cosine, but we've been thinking it in terms of the unit circle. What is the angle that has this sine value? When I plug this into my calculator is going to give me the value that has, or excuse me, the angle that has a sine of negative 0.123. And so I found this, and by the way, if you want to get TI emulator software on your Chromebook, do it now. I think because of the whole COVID-19 situation, TI has gotten a little bit more giving in their software. Usually you have to pay for this or buy a license for this, but it is free right now. I just went to the TI website earlier today and downloaded this software. I am going to need to switch my calculator into degree mode. So I hit the mode button, and then I'll go down and switch this over into degrees. Otherwise, it's going to give me angles that are in radians. Let's see. And then I wanted the inverse sine. I don't know if the resolution on my videos are good enough that you can see this, but the sine function has a second function of the inverse sine. I hit the blue second button to activate that. Inverse sine of negative 0.123. And again, this is me asking my calculator what angle has a sine value of negative 0.123. I hit enter and it gives me that angle. So negative 7.065, negative 7.065. Negative 7.065. Remember, way at the beginning of this lesson, we saw that the value that my calculator gives me for this one is always going to be a value between negative 90 degrees and 90 degrees. So actually, the answer that I got from my calculator is not in the range of values that I'm looking for between 0 and 360 degrees. So I'm going to have to think about this in terms of the unit circle. If I want to get both of my values, my calculator gave me this one. It gave me this little tiny negative 7-degree angle. But there's another place on the unit circle that's going to have that same sine value, this negative 0.123. That's this little tiny length right there. And the other place on the unit circle that's going to have that as its vertical component is this one over here in the third quadrant. So my calculator tells me that this little tiny angle over here is negative 7.065. To get my answer between 0 and 360 degrees, well, that's 7.065 less than 360. So I'm going to do 360 minus 7.065. Calculator tells me 352.935. And then the one that's over in the third quadrant, that's 7.065 degrees more than 180 degrees. So I'll do 180 plus 7.065. And I get my last answer of the day, 187.065. So that is the idea for problems like that. Your calculator will only give you one of them. Your calculator will only give you the principal value. You're going to have to use what you know about the unit circle, sines, cosines, to figure out the other one. All right, I feel like my voice is going at this point. I've been talking so long. So thanks for sitting it out. Actually, as a little reward for those of you who made it this far, here's a little treat for you. This is on our Disney vacation somewhere. I think this picture is mostly funny because of Sylvia's brother, Luke, who's peeking out behind his sister there. But there we go. That's enough of that. Oops. I'll stop this video at this point. Hopefully this all made sense. If not, certainly send me questions or comments, and we will see you again next time I see you. Bye-bye.